Hello, this is Fifth, and today I'll go through chapter 5.2, which deals with electrical circuits. First, you need to identify different elements in circuits. At the top, we can see a battery. A battery has a positive and negative side. How can you remember which side is which? Well, you can split the big line kind of like two small lines, so top each other you get a plus. And this small line just becomes a minus. Current goes through from positive side to negative side. Next up, we have a resistor, and this is a different drawing of resistor. A resistor has some specific resistance. Power loss in a resistor is voltage times current. Next up, there is voltmeter. Voltmeter measures voltage difference between 2 points or voltage across components. Ideal voltmeter has infinite resistance. For that reason, it has to be put in parallel with other components. Next up, there is ammeter. Ammeter measures current that goes through the ammeter. Ideal ammeter has zero resistance. For that reason, it has to be put in series with other components. Series means that components go one after each other, while in parallel means that components are next to each other. Next up, there is Ohm's law. Ohm's law says that there is proportionality between voltage and current. So you can multiply current by some constant and get voltage in a component or in a circuit. Often you can change or name this constant as resistor or resistance. However, this resistance is not constant for all currents in all components. Example is lamp filament. In here, resistance changes depend on the current. To find the resistance at specific point or specific voltage and current, you just need to find the current and the corresponding voltage on the graph, divide one by another, and you get the resistance. However, usually in resistors, the resistance is constant, so this law will be generally true. What's the analogy to Ohm's law and electricity? Analogy is water flow. So, for example, current is water, pipes are wires, so you have some kind of water that goes through pipes. What's resistance? Resistors with some specific resistance. Those are smaller pipes. So like smaller pipes. And that's how a circuit would look like. So there will be a kind of resistor here. So since current of water in this case has trouble going through this small pipe, there is some kind of resistance which changes the amount of current that can flow through it. What's a battery? A battery is like a pump that pumps water. So it gives some kind of pressure to the system. Those voltage can be thought of as pressure. So pump is giving pressure, allowing more water to flow through it. So this is how it would look like. So from positive to negative current in this direction. Those voltage is pressure, current is amount of water, and resistance is how thin the pipes are. Analogy is not perfect, but it gives you an idea why this Ohm's law works. Next up, we can try to calculate resistance of resistors in series and parallel, because often we want to simplify circuits to make it easier for us to calculate. So, for example, when you have 3 resistors, you want to simplify it to one resistor with the same resistance. So, what do we do when it's in series? We just sum up this resistance and we get the final big resistance R. So if we replace this resistor with resistance R, which is the sum of original resistances, then you have the exact same circuit. If we have parallel, we do a different thing. We do inverse of each resistance, we sum them up, and then we get 1 over actual resistance of all 3 resistors at the same time. Next up, we have resistivity. Resistivity is property of materials because resistance depends on a lot of factors such as volume, length of the wire, etc. Resistivity shows property of different elements such as copper or any other materials, thus allowing us to calculate resistance easier if you know the length and the radius or the volume of a wire or object. Usually this formula is used to calculate resistance of a wire because those have constant radius, those allowing to use this formula quite easily. So resistivity is equal to resistance times the cross-section area of a wire divided by the length of a wire. So bigger the length, or smaller the cross-section, the bigger the actual resistance. The units for resistivity is ohms times meters, not ohms per meter, which is a common mistake. You can find cross-sectional area from radius using PR squared. Next up is Kirchoff's laws. There are two laws, and I'll show both of them. First law is a voltage law, which says that in a loop, so a loop is a closed wire, so that if you start at some specific point and you go along the wire, you come to the same point at the end. It says that if you go around the wire and calculate the voltage drops, then the voltage drop in total will be 0. That's because battery provides positive voltage and resistors have voltage drop. That's why all resistors have to have the same voltage drop as much as battery gives it. Second law deals with currents. It says that in a junction is a place where one wire splits into several wires, the sum of currents is 0. What it means is that I1 is equal to I2 plus I3. So we don't get any extra current out of nowhere. So I1 has to split into two currents. So in other words, sum of currents in a junction is 0, because those are opposite signs. So I2 and I3 is opposite sign to I1. So sum of them will be 0. And I'll show one example on one of the laws, the voltage law to be precise. Here I have a circuit with two batteries. If you try to apply Ohm's law directly, trying to find the resistance of different resistors, parallel or series, you won't get anywhere, because current goes maybe from here, but then it splits, and then the second battery doesn't work like that. So you have to use Kirchoff's law. If you're gonna use loops or voltage law, then we need to find the loops. And for example, there is loop 1, to name it 1, and then find loop 2. There's actually a third loop if you think of it like this, but we'll quickly find out that we don't need it, so I'll just remove it for now and explain why we don't need it later. Next up, since we go in a loop, we need to find the starting point. So let's say this is starting point for 1, this starting point for loop 2. And finally, we need to identify current direction in each of the loops. So for example, here current can go from here, 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 here. And in second loop, current goes from here, 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 and back to the battery. Okay, question is, why did I choose these directions for the loop and this direction for the current? It's totally random. You could choose different one. You get the same answer. Doesn't matter. I just want to choose this one, so I'll just go with this one. You could choose different one and you will still get the same answer. Okay, first we need to identify the loops, then we found the start point, and finally we found the current direction in each of the loops. Now we need to apply the actual law. So what does the law state? Law states that voltage drop across the loop is 0. Okay, let's start with the first loop. So first loop, we start at this point, we go in the direction of the loop, we come to the first red resistor, and let's remember Ohm's law. Voltage equals current times resistance. So voltage drop across the resistor. So we have first current, let's name it I1, times the resistance of the red resistor, which is 4. Use different color. However, since the current is in the same direction as we move in the loop, it means that we have a potential drop across the resistor. Thus, it will be negative, so it's drop. The negative sign shows that it's drop. So for example, we have resistor, current in this direction and we move in this direction, then it will be negative sign. If you would move in different direction, then it will be positive sign. Okay. And then we go down because that's where a loop goes, and we come to the green resistor. Okay, we move in the same direction as current, we have potential drop. Okay, then I1 as we did previously. However, we need to remember that we have second current, the light blue current going through the same resistor. So we need to sum up those currents because this light blue current goes in the same direction as our loop. And multiply by our resistance, which is 2. So let me repeat that. Why do we have second current right here and why do we sum it up? First, why do we have it? Because it goes through the same resistor. Red one goes through here, light blue goes through here, so it goes through the green resistor, but not red one. Thus we didn't have it in red one, but we have it here. Why do we sum them up? Because it's in the same direction as our loop, so both would be negative. And if you open the brackets, both would be negative. Okay, we're done with the green resistor. We come to the end, almost to the end of the loop. However, first we have a battery. Since it's from negative to positive, we have potential gain, so it's plus 28 volts. How to remember it? Well, it's like from small to big step. Since it's in the same direction, we have a potential gain. And then we come to the end of our loop, so where we start from. And from the law, potential drop across the loop is 0, so we have to equal to it to 0. Okay, then we have second loop. We start here before the battery because I want to. It doesn't actually matter where I start. Okay, first we come to the battery. From negative to positive, we have potential gain 7 volts. Okay, we come to the light blue resistor. Current in the same direction as our loop, so we have negative. So yeah, this is of course I2 current times our resistance, which is 1. Okay, then we come to the green resistor. However, we need to remember that there is also a red current that goes through it, as well as light blue current. Since its current is in the same direction as our loop, we have negative sign, and we sum up those currents. So yeah, of course, if the red current would be in different direction, we would have to have negative sign right here. However, if they're in the same direction as our loop, thus we both would be negative, as without brackets. So in brackets, there will be sum of those currents. And then multiply by the resistance 2. We sum up all those potential drops because we come to the end of the loop, and the potential drops should be 0 from the law. Okay, so now we have two unknowns and we have 2 equations. Just solve for 2 unknowns, I1 and I2, and you get the answer. So if you actually do it properly, you get that I1 is 5 amps and I2 is negative 1 amp. Okay, we need to think whether it makes sense, because sometimes you might get something wrong, and it's good to ask question at the end of exercise. Does the answer make sense, or did I make a mistake? 5 amps, so the current that goes through this battery kind of makes sense. It's same magnitude, it's positive. However, second answer, it's negative. Does it make sense? It does make sense to have negative mass, but does it make sense to have negative current? In this case, yes, it does, because it means that current direction is not as I have drawn with the light blue color, but in the opposite direction, so green color. So if I would identify current in this direction, I will get positive 1 amp. So in this case, yes, this makes sense. So some of you might ask, what's a current flow through the green resistor? Well, you just need to sum up all the currents going through it. So in this case, 5 minus 1, 4 amps through this one. The red resistor, of course, it's I1, which is 5 amps. And light blue resistor, it's 1 amp. Thank you for watching.